Poverty prediction using random forest-based machine learning technique. Based on multidimensional poverty concept. Abstract poverty is an heterogeneous problem and it varies according to time and geographical location. Our study focuses on 1. A method based on multidimensional concept to predict poverty by taking various household characteristics. 2. A novel feature extraction framework to find a feature that put household in a specific class of poverty. 3. Defining 4 classes of poverty instead of 2 traditional levels, poor/non-poor. We make use of random forest machine learning algorithm for more accuracy and we will divide data sets into multiple individual data sets. Keywords: random forest, multidimensional poverty, poverty levels, data sets. Introduction. Poverty prediction and classification is tough, expensive, and time-consuming. Achieving accuracy is complicated because of data scarcity and security. It may still be hard to define poverty even when various different data are collected from households. Measurement of poverty has 2 separate complications. I. Poverty identification. 2. Creation of an index to measure poverty. Income is classically used to overcome the first problem, but the second part is long debated by researchers and practitioners. Based on the multidimensional poverty concept, we predict poverty level. Multidimensional poverty index algorithm is responsible for analysis of different data given by the algorithm executor in order and then determines the level of poverty the user is having. Randomized forest algorithm divides the entire data set into set of multiple independent rows. For each of the independent data set, the C4.5 algorithm is executed. The 5 different independent C4.5 algorithms are executed and then class label is generated. After the set is formed, the maximum count of class label is found out and then class is determined. 2. Exciting system. Multidimensional poverty index constitutes the first implementation of the direct method to measure poverty for over 100 developing countries. Multidimensional poverty index, MPI, a measure of acute poverty, understood as a person's inability to meet minimum international standards and indicators related to the Millennium Development Goals and to core functionings. The MPI offers a reliable framework that can complement global income poverty estimates. Disadvantage. 1. The method considers the family income of the end user, computes the average income, and if it is below the threshold set by MPI review, the user is classified into poverty and non-poverty. 3. Problem description. Figure 1, problem description. Normalization of data rows. This module is responsible for dividing the actual row data with the value highest among all the rows specific to each of the columns. MPI-based classification. This algorithm is responsible for analysis of different data given by the algorithm executor in order and then determines the level of poverty the user is having. The detailed steps can be found as below. 1. Obtain the list of attribute 1 from the previous history data set for users who have the poverty level label. 2. Obtain the list of attribute 2 from the previous history data set for users who have the poverty level label. 3. Compute the summation of list of attribute 1. 4. Compute the summation of list of attribute 2. 5. Compute the mean of attribute 1. 6. Compute the mean of attribute 2. 7. Compute the standard deviation of list of attribute 1. 8. Compute the standard deviation of list of attribute 2. 9. Compute the probability of attribute 1. Randomized forest. Randomized forest algorithm is responsible for dividing the entire data set into set of multiple independent rows. For each of the independent data set, the algorithm is executed. The 5 different independent algorithms are executed and then class label is generated. After the set is formed, the maximum count of class label is found out and then class is determined. Architecture. Figure 2, System Architecture. For implementation. Software development which can be delivered fast, quick adaptation to requirements and collecting feedback on required information. The Agile software methods and development is practices-based approach empowered with values, principles, and practices which make the software development process easier and in faster time. Agile methods which encompasses individual methods like extreme programming, feature-driven development, Scrum, etc. are coming into the commercial and academic worlds. Agility refers to the quality of being agile. Internet software industry and mobile and wireless application development industry are looking for a very good approach of software development. Conventional software development methods have completely closed the requirements process before analysis and design process. In contrast to the conventional approaches, Agile methods allow developers to make late changes in the requirement specification document. The focus of the Agile software development as given by Agile Software Development Manifesto is presented in the following. O. Individuals and interactions over processes and tools. O. Working software over comprehensive documentation. O. Customer collaboration over contract negotiation. O. Responding to change over following a plan. 1. There is vital importance of communication between the individual who are in development team, since development centers are located at different places. The necessity of interaction between individuals over different tools and different versions and processes is very vital. 2. The only objective of software development team is to continuously deliver the working software for the customers. New releases must be produced for frequent intervals. The developers try to keep the code simple, straightforward and technically as advanced as possible and will try to lessen the documentation. 3. The relationship between developers and the stakeholders is most important as the pace and the size of the project grows. The cooperation and negotiation between clients and the developers is the key for the relationship. Agile methods are using in maintaining good relationship with clients. 4. The development team should be well informed and authorized to consider the possible adjustments and enhancements emerging during the development process. Implementation architecture. The user interface is designed in the HTML/JSP pages and then the request goes to the web container and web container verifies the request in the web.xml file by looking first into the URL pattern and then it goes to the servlet name and then it searches for the corresponding servlet name in the servlet tag and looks into the servlet class and creates an object of action servlet and then the action servlet will delegate its job to request processor. The request processor will look for the action to which must be called and looked up in the stuxconfig.xml and corresponding action form is called and then the action is called. The action class will then call the delegate, then the delegate calls the service and service calls the data access layer and results goes exactly in the opposite way and the resultant JSP page is loaded. V results. The MPI classification input in which there are multiple values provided by the end user in order to determine the category in which the following attributes. The classification result for the MPI algorithm. As shown in the fig cluster number which is predicted is 4 and the class label is non-vulnerable. The details why class is predicted as non-vulnerable is based on highest probability. The random forest algorithm input. In this algorithm the various attributes of the algorithm are discussed. The input attributes are taken into consideration which is responsible for analysis of the data and then executing the random forest algorithm. The time taken for various algorithms. The random forest algorithm will have lowest time taken across all the iterations as compared to MPI method. As shown in the fig, the accuracy of the proposed method is 100% as compared to previous method whose value is 92.85%. 6. Conclusion. The data sets are divided into multiple independent data sets. For the MPI algorithm all the data rows will act as an input and then prediction of MPI class label is obtained. The random forest algorithm will have divided the entire data sets into multiple independent data sets. From each dataset the output class label is determined if each of the decision tree, the process is repeated for the remaining decision trees. The count of output class label is taken into consideration and the actual class is determined. The comparison of MPI method with random forest is compared across all the iterations and the time taken by proposed random forest will be lesser than that of MPI method. The accuracy of random forest algorithm is compared with MPI. The accuracy of the proposed method is always higher.